Hello everyone. In this video, we will talk about discrete probability distributions. Recall in the previous video, we have some example talking about the PMF. The PMF of a discrete random variable can be represented by a table, a graph, or a formula. The PMF provides the probabilities denoted as the big P of the random variable x evaluated at a particular value of x or P of x, corresponding to every possible values of x. The PMF of a discrete random variable possesses the following two characteristics. For each value of x, the value of P of x must be between 0 and 1. And the summation of all the value of P of x over all possible value of x equal 1. Let's move on to the definition of the CDF, the cumulative distribution function. The CDF of a discrete random variable is given by the big F of x. By definition, it is equal to the probability of a random variable x less than or equals to a particular value, small x. This is equal to the summation of all values of P of y, where the value of y is less than or equals to x. The CDF of x gives the probability that the random variable x takes a value less than or equals to x. Here are some properties regarding the CDF. The limit of the CDF of x equals 0 when x approaches negative infinity. And the limit of the CDF of x equals 1 as x approaches positive infinity. And the CDF is a non-decreasing function, and it is right continuous. Let's take a look at an example. Let x be the number of courses a student enrolled in the current semester at ABC University. And the PMF of x is depicted below. From the PMF, we can see that at x equals 1 corresponds to a student taking one course in the current semester. The PMF is 0.03. When x equals 2, corresponds to the number of courses a student enrolled in the current semester is 2, the corresponding PMF is 0.04. This is the full PMF table. You can verify that if you sum up all these P of x values, you should get 1. And here we have a graph of the PMF of x. So at x equals 1, P of x is 0.03. At x about here, x equals 4, the PMF is 0.28. And at x equals 5, the P of x equals 0.35. Let's take a look at the evaluation of the CDF. The CDF at x equals 1, by definition, equals to the probability of x less than or equals to 1. So this is 0.03. And then the CDF evaluated at x equals 2, by definition, it is equal to the probability that x is less than or equals 2. So x can take on value 1 and 2. So we sum up P of 1 and P of 2. 0.03 plus 0.04, we get 0.07. This is the probability that a student will take 1 or 2 courses in the current semester. And then f of 3 equals the probability that x is less than or equals 3. So x can take on value 1, 2, and 3. Sum up the corresponding P of x, P of 1, 0.03, plus P of 2, 0.04, plus P of 3, 0.22, we get 0.29. So 29% of the students in the university takes 3 or fewer courses in the current semester. Similarly, we can get the value of f of 4, f of 5, and f of 6. F of 4 equals 0.57, f of 5 equals 0.92, and f of 6 equals 1. So this is a table depicting the PMF of X as well as the CDF of X. Let's get back to the definition of the CDF of X. The CDF of X equals the probability that a random variable is less than or equals to X. So we will sum up all the value of P of Y, where Y is less than or equals X. What if we want to evaluate the CDF of X where X is not an integer? In our example, X must be an integer. X equals 1, 2, 3, 4, 5, and 6 only. Then what is the CDF evaluated at 3.5? By definition, it is equal to the probability that X is less than or equal to 3.5. And in our example, the event X less than or equals to 3.5 is the same as the event X less than or equals 3. So we simply compute the probability that X is less than or equals 3, and the corresponding value is 0.29. So the CDF evaluated at X equals 3.5 is 0.29. How about f of 3.99? This equals the probability that X is less than or equals to 3.99. And it is the same as the probability that X is less than or equals to 3. So we get the same CDF of X when X equals 3.5, which is 0.29. How about the CDF evaluated at 4.001? So the value is the same as the CDF at X equals 4, which is 0.57. And the CDF at X equals 5.2 is the same as the CDF evaluated at X equals 5, which is equal to 0.92. Here we have the full CDF. When X is less than 1, the CDF is 0. When X is greater than or equals to 1 but less than 2, the CDF is 0.03. The value of the CDF is 0.07 when X is greater than or equals to 2 but less than 3. And similarly, when X is greater than or equals to 3 but less than 4, we get a CDF equals 0.29 until the end. When X is greater than or equals to 6, the CDF value is 1. On the right-hand side, we have the graph of the CDF. For example, at X equals 3, the CDF value is 0.29. And the value of the CDF is constant as X moves from 3 to 3.99999 until X equals 4. The CDF jumped from 0.29 to the value 0.57. This corresponds to the value of f of 4, 0.57 here. And then this value of CDF 0.57 remains constant until X reaches the value 5. the CDF will jump to 0.92, corresponds to the value f of 5. And until x reach 6 or above, the CDF is 1. From the graph of the CDF of x, we can verify the 4 properties. The limit of f of x equals 0 when x approaches minus infinity. The limit of f of x equals 1 as x approaches positive infinity. The CDF is a non-decreasing function, and it is right continuous. Let's take a look at a series of probability questions. If a student is randomly selected, what is the probability that the student enrolled at most 3 courses? This corresponds to the probability statement P of x less than or equals 3. So x can take on value 1, 2, and 3. This corresponds to the CDF evaluated at x equals 3, whose value is 0.29, or we can add up the corresponding PMF value. We add up 0.03, 0.04, and 0.22. We also get the value 0.29. Let's take a look at the next question. What is the probability that the student enrolled in fewer than 3 courses? The corresponding probability statement is P of x less than 3. This corresponds to the value of x equals 1 and 2 only. By definition, this is equals to the CDF evaluated at x equals 2, which is 0.07. Or we can sum up the value P of 1 and P of 2. We also get 0.07. How about the probability that the student enrolled in at least 3 courses? We have P of x greater than or equals to 3. The corresponding value of x in this probability statement is x equals 3, 4, 5, and 6. Sum up the corresponding PMF value, P of 3, P of 4, P of 5, and P of 6. We get 0.93. Let's make use of the value of the CDF. The event x greater than or equals 3 corresponds to the value x equals 3, 4, 5, and 6. And then the remaining value of x equals 1 and 2 corresponds to the event x less than 3. The event x less than 3 and the event x greater than or equals to 3 are mutually exclusive, and they are exhaustive events. So the probability of x greater than or equals to 3 equals 1 minus the probability of x less than 3. And the probability of x less than 3 is the CDF evaluated at x equals 2, and f of 2 equals 0.07. So the expression 1 minus f of 2 equals 1 minus 0.07, which equals 0.93. How about the probability that the student enrolled in more than 3 courses? The corresponding probability statement is the P of x greater than 3. This corresponds to the events x equals 4, x equals 5, and x equals 6. So we sum up the corresponding PMF value, 0.28, 0.35, and 0.08. We get 0.71. And we can also get this number by using the CDF value. The event x greater than 3 corresponds to the value x equals 4, 5, and 6. And for the event x less than or equals to 3, this corresponds to the remaining value of x equals 1, 2, and 3. So we have these two events, x less than or equals to 3 and the event x greater than 3, mutually exclusive and exhaustive. So the probability of x greater than 3 equals 1 minus the probability of x less than or equals 3 equals 1 minus the CDF at x equals 3, which is 0.29. So we get the same value, 0.71. Let's move on to the next one. What is the probability that the student enrolled in between 2 and 5 courses inclusive? Write out the corresponding probability statement. We have the probability that x is greater than or equals to 2 and less than or equals to 5. The corresponding value of x is x equals 2, 3, 4, and 5. Sum up the four values of P of x, 0.04, 0.22, 0.28, and 0.35. We get 0.89. Let's use the value of the CDF. Okay, the probability when x is between 2 and 5 inclusive. So we will consider the event x less than or equals to 5. This corresponds to the value of x equals 1, 2, 3, 4, and 5. But we only need the value when x equals 2, 3, 4, and 5 only. We don't need the value x equals 1 in our calculation. So we will take the event x less than or equals 5, subtract the probability for x less than or equals 1. So we get the probability of x less than or equals 5 minus the probability that x is less than or equals 1. This equals f of 5 minus f of 1. F of 5 equals 0.92, and f of 1 equals 0.03. So we get the expression 0.92 minus 0.03 equals 0.89. That's it for today's video. Thank you for watching. In the next video, we will talk about the expected value and the variance of a discrete random variable.